Hello everyone, I welcome you all for the course Manipulator Robotics. It's a theory course. Today's topic is derive manipulator Jacobian for RPY manipulator. So derive manipulator Jacobian for RPY manipulator. Okay, so it is all of 3R only. So we have to take the rotary Jacobian. We know that the rotary Jacobian formula is Pi minus 1 cross Pn I minus 1, and then the lower one is Pi minus 1. This represents linear velocity. This represents angular velocity. Okay, so this is equal to Jacobian. So we are going to discuss now. So what is J1? In the place of I, replace 1. Okay, so now your Pi minus 1 becomes P naught cross this order of the manipulator is 3. So P3, 0, and here P naught. Okay, then J2. So J2 replace I by 2. So 2 minus 1 is P naught cross P2, 1, and P1 is position vector. Then J3 is replace I by 3. It becomes P2 cross. So here P3, yeah, because the order is we have P3, 2, and P2. Okay. So we have discussed already how to derive P naught. So P naught equal to R naught naught I vector. Okay. So R naught is a identity vector. So the if you multiply this, you will get only 0, 0, 1. Okay. Yes. And then we need to find out P3 0. Okay. So P3 0 formula is Tn 0 On minus T I minus 1 0. So one second here. Okay, before this, first let me give you this matrix. Okay, so for all this, we need T10. So T10 is C1 0 S1 0 S1 0 minus C1 0 0 1 0 0. So how did you get this one? That means in the DH table, your DH table for this, let me recollect your DH table. So your DH table is 90 degrees alpha, A is 0, D is 0, and theta is theta 1. If you substitute in the DH transformation matrix, you will get this T10. Okay, so this is your T10. Okay, and let me rub it. So in that way only we will get this matrix. Okay, so next we will take the next one. So which is 2, 1. You have to take the second row of the DH table and substitute in the DH matrix. Okay, so it is minus S2 minus S2 0, C2 0, C2 0, S2 0, and 0 1 0 0 0 0 1. Okay, so this is my T2 1. Okay, and also T3 2. T3 2 is equivalent to, so it is C3 minus S3 0 0 and S3 C3 0 0 and 0 0 1 0 0 0 1. Okay, so we got these transformation matrix from when you have to use the DH table. Then the DH table parameters are to be substituted in DH transformation matrix, and then from there we have to take this matrix. So this is the transformation matrix. Okay. So now let's do each. I mean everything we are going to calculate now. So let's see one by one. Okay. And then why do we need this transformation matrix is because we need to calculate the position vector. Okay. So now we know this P naught. So now we have to derive here P30. Okay. So P30 formula is Tn is T3. Okay. T30 O3 minus T, because I minus 1. So I minus 1 is 0, 0, and then O3. Okay, actually the formula is Tn0 On minus Ti minus 1 O with respect to ON. So this is the formula. So this is Pi minus 1. Sorry, so this is Pn I minus 1. So Pn I minus 1 is, this is the formula. It is when you multiply this transformation matrix by the origin vector or unit vector, you will get the translation portion, that is the position vectors. Then this is with respect to this. So for that, you have to take, so this one we have already discussed in the last class itself. Suppose if you have this joint, then here you have base joint, then you have various link. Okay, so finally you have one link. Here is the end effectors. This is the end frame. This is zero frame. This is I minus 1 frame. This is I. Okay. So if you want to give this position vector means position n with respect to O. And then if you want to give this position vector means position I minus 1 with respect to O. Then if you want to give this means Pn with respect to I minus 1. Okay. So what is Pn minus Pn0 equal to addition of Pi minus 1 0 plus Pn I minus 1. Okay. Then I want Pn I minus 1, Pi minus 1 equal to Pn0 minus Pi minus 1 0. Okay. Just for given away, see this Pn. How did you get this position vector? By multiplying this unit vector with the homogeneous transformation matrix. So that is why Pn0 On minus Pi minus 1. So that's what. Okay. So now we have derived this. I mean, we have declared, defined what is P naught and then what is P3 also. Okay. So let me continue. So now we have discussed the equations. Straight away, we are going to substitute in that J1 matrix. Already I have given the matrix. Okay. So for that purpose, we need this transformation matrix. So T30 is equivalent to, we have to multiply that C1, you have to multiply all the matrix. So minus C1 S2, C3 plus S1 S3, C1 S2 S3 plus S1 C3, C1 C2 0. And then next one is minus S1 S2 C3 minus C1 S3, C1, because already I have calculated this, that is why I'm just copying that, the calculated one. Okay, C1, C3, and then S1, C2, 0. Okay, so C2, C3 minus C2, S3, then here S2, 0, 0, 0, 0, 1. Okay, so already we have calculated P1. Okay, so this is multiplied by T through T21 multiplication T1 0. If you multiply all these three, you will get this answer. Okay. So let's come back to this formula. So what is P3? P30 is P30 O3 minus 0 3. And then here your I minus 1 is, the formula is I minus 1. So I minus 1 minus 1 is 0. So T3 0 and O3. Okay. Okay, so this one is 1 second. I think I minus 1 0 1. So I minus 1 is, so here's 0. Okay, so better let me write the formula. So here Pi minus 1 0 equal to Tn0 On minus T I minus 1 O and O3. So this is the formula. So let me substitute here. So this in this it has I is 1, so 0. Okay. So T3 0 into O3 means, so this is my T3. And then if you multiply it by O3, okay, so this T3 0, O3 0, 0, 0, 1. Okay. If you multiply by this means, so you will get the last this translation part only. Okay. So if you multiply that, so minus, and then this is unity matrix. So here also you will get 0, 0, 1 only. Okay. So when you multiply, you will get this only. So the answer is 0, 0, 0. Yeah, this one is P3 is 4 zeros. Okay, this is the one. Okay. So now what is J1? J1 equal to P naught cross P3 0 P naught. So already we have derived your P naught 0, 0, 1. That is cross multiplied with 0, 0, 0. And then here 0, 0, 1. Okay. So if you cross multiply this, you will get only 0, 0, 0, 0, 0, 0, and then 0, 0, 1. So this is my J1. Okay, so let me do J2. So J2 is P2, sorry, P1 cross P31, P1. So this is the formula. Okay, so let's do what is P1. P1 is R10 into I cap, I mean unit vector. So what is R10? So you have to check the first matrix T10 in that part. So your R10 is C10 S1 and S10 minus C1 0 1 0, because from the transformation matrix I have taken the R1 part, I mean the rotation part. So that is multiplied by 0 0 1. If you multiply this, you will get this last row. So last row is S1 and last column is S1 minus C1 0. Okay. So this is my P1. So next you have to calculate P31. Okay. So what is P31? So T30 O3 minus this I minus 1. I minus 1 is 1. Then here is 3. Okay. 1 3. So this is 0 0. Okay. And then T1 0 into O3. Okay. So T3 0 into O3 is already we have found out. So that is, if you subtract this, you will get 0 0 0. Okay. This matrix is given, so just multiply and subtract. Okay. So now we have to do J2. So what is J2? S1 minus C1 0 cross multiply 0 0 0. Then here S1 minus C1. Okay. Minus C1. So when you cross multiply, so this one 0 0, when you cross, so it is 0 0 only. So 0 0 0. Okay. And then here S1 minus C1 0. So this is my Jacobian, my second Jacobian. Okay. So let's do the third Jacobian. So third Jacobian formula is P2 cross P32 and P2. So what is P2? R20, I mean unit vector. Okay. So what is R20? So we have only, okay, let me, R20 means it is R10 into R21. We have to multiply this with I vector. Okay, so let's multiply. So already we know that C1 minus S1, C1 S1. So S1 0 minus C1 0, 0 1 0 0 0 0 1. Okay, so this is multiplied with the next matrix minus S2 0 C2 0 C2 0 S2 0 0 1 0 0 0 0 0 1. Okay, and then the 0 0 1. Okay, so now so in this we have to take only this rotation matrix. So rotation matrix only. So we don't need this. because rotation matrix only. Okay, so let's have it. So now we'll multiply this thing. So it is when you multiply it is minus C1 S2 0 then 0. Okay, then here this is 0, this 0. You have S1. Then when you multiply this C1 C2 this 0, then you have 0. Okay. Then next term is minus S1 S2 minus C1 S1, C2. Okay. So here we have C2, 0, S2. Okay. So when you after this, then you have to multiply this with 1. So whenever you multiply this with this means this will be retained. So the answer is C1, C2, S1, C2. So this is my position vector 2. Okay. So let's do the next one. So next one is P32. So what is P32? T3003 minus T2043. Okay. So if you subtract this, it will be 0, 0, 0 only. Okay. So now we have to do this Jacobian. So this J3 is equivalent to P2. So already we have derived P2. So what is P2? C1, C2, S1, C2 and S2. So this should be cross multiplied with 0, 0, 0. Okay. Then you have C1, C2, S1, C2, and S2. So whenever you cross multiply this, you will get 0, 0, only 0, 0, 0. Then here C1, C2, S1, C2, and S2. Okay, so this is my J3. Okay, so now we have to combine all the Jacobians. So which is J1, J2, J3. Okay, so let's see J equal to J RPY equal to J1, J2, J3. Okay. So let's combine everything. So it is first one is 0, 0, 0, 0, 0, 1. Okay. Second one is 0, 0, 0, S1 minus C1, 0. And the next one is 0, 0, 0. It is S1, C2. So this one C1, C2. C1, C2, S1, C2, and then S2. C1, C2, S1, C2, and S2. Okay. So what is the order of the Jacobian? 6 cross n. So here order degree of freedom is 3. So this is 6 cross 3. Okay. So in this way, we have to find out the Jacobian. So the summary is Jacobian is which is a mathematical model which relates the relationship between the end effector velocity and the joint velocity V equal to Jacobian Q dot. So this is the thing. So this Jacobian, it has the matrix order is 6 cross n. The 6 comes from linear velocity in all the directions and angular velocity. Okay. So this is how, and then this n represents the order of the system, or I can say the degree of the freedom. Okay. Then in Jacobian, we have two things. One is rotary Jacobian, another one is prismatic Jacobian. So rotary Jacobian is Pi minus 1 cross P n I minus 1 and then Pi minus 1. And then for prismatic, Pi minus 1 and 0. Okay. So just substitute, and these are all position vectors. So how do you get the position vector? When you multiply a unit vector with the transformation matrix, means you will get the position vector. So we have applied that formula and we have derived it. Okay. Thanks for watching.